Now we'll try to solve the following Olympiad math problem. So in this case, we are given 3 to the power a minus 3 to the power b equals 2024 with a, b positive integers. So the key idea here is that we first need to write 2024 as a prime factorization. So if we keep dividing by 2, we get 2 to the power 3 times 11 times 23. If my computation is right, I didn't check it. So now we have 3 to the power a minus 3 to the power b equals this number. That means here is that 3 to the power a is bigger than 3 to the power b. Okay, since we have the same basis, this means that a is bigger than b. So this is the first condition that we get. So, and we start from here. So what does it mean when a is bigger than b? That means a is b plus some k, some other number. Okay, so there is a difference between a and b, which is we call k. Okay, we will use it here and we try to solve. Okay, so let's see. So let's plug a here and we see what we can do. So this is 3a minus 3 to the power b is 3 to the power b plus k minus 3 to the power b equals 2 to the power 3 times 11 times 23. So let's factor here by b. So we get 3 to the power b times, or factor of 3 to the power k minus 1 equals 2 to the power 3 times 11 times 23. Okay, here we need to see some things. So 23, 11, 2, and 3 are all prime numbers. That means they can divide themselves, or their divisor are only 1 and themselves. So only 23 can be divided by 23. Okay? But here, this number here, since 3 can't be divided by this 11 and 23, so the only one left is 3 to the power k minus 1. It must equal to this one, to 2 to the power 3. Okay? And another key idea that we get is that 3k is always an odd number. When we subtract 1 from it, it's an even number. And the only even number here is 2 to the power 3. That means 3 to k minus 1 equals 2 to the power 3. And this is 8. That means 3 to the power k equals 8 plus 1, which is 9, which is 3 to the power 3. That means k equals 3. Okay? So now we have k equals 3. We're gonna go back and see what we can do. Okay? So this means that plugging here, we have 3 to the power b is equal to 11 times 23 after we cancel by this number, 3 to the power k minus 1, which is 8, which is 2 to the power 3. So we have 3 to the power b equals 11 times 23. Okay? But in this case, this means that 3 can divide 23. or 3 can divide 11. But 3 and 11 are primes. 3 and 23 are primes. They can't divide themselves. Okay? That means there is no such b. Okay? So there is no such b. That means there is no such number, an integer, that solves this equation. And since there is no b, there is no a. Okay? Because we have proved that b and a are related by this relation. Okay? And therefore, there is no solution for this one such that a and b are integers.